GM, and we are now live for a new workshop from the open house happening in India right now. So first of all, thank you so much for jumping in this live stream with me. I'm Lorenzo. I am working in the Arbitrum Foundation, and today we're gonna talk a bit about open house and then going through the workshop that we have today, that is basically an introduction to the dev tooling we have, and we're gonna basically explain a bit of things you could use to build your projects during the open house. So let me make this a bit bigger and we can kick things off. Now, yes, I'm Lorenzo, working in the Arbitrum Foundation. I'm the head of technology. Today, I'm replacing one of my colleagues, Ben, who is the creator of the workshop. So I hope I will deliver as it would. And we can basically start by talking a moment about open house and what's going on. First of all, if you didn't join the online Buildathon of Open House India, you still have time. You can scan this QR code and you will land on our website where you can basically still sign up. You fill a couple of questions and then you create your team and start your project and you start to build. Now, what is Open House? Open House is a multi-step activations. We started a few weeks ago with learnings and now is live the online Buildathon. It will run for the next 14 days. So you have a bit of time to build your projects. And then we're gonna basically have an in real life event in Bangalore for an hacker house of 4 months. Interesting things here is there are prizes for the online Buildathon. You can get up to 33K USD dollars in 3 main prizes, first and second and third positions. But then we have also honorable mentions in DeFi, AI, gamings, and many others. So you can definitely spend a bit of time here trying to build something that makes sense and be part of the possibility to win one of those prizes. Another thing that I want to highlight about the online Buildathon is that you can also bring your own code. If you have a project that you're building, if you are a team that's building on Arbitrum and in any of those categories, or even if you're not within our categories, we're still very, very interested to see what you're building. So it's not about specific tech, it is about problem solving, something that makes sense for the end users, and basically present it to the Buildathon. Okay, that is about the Buildathon. As I said, you can scan the QR code and you will land in our Buildathon. Now, what's the workshop objective? So today we're gonna start and use the Arbitrum toolbox. We're gonna deploy contracts in Solidity, in Stylus, and we're gonna connect those contracts on a React front end. And also we're gonna play a bit with the tools such as like Cargo and Foundry and VM, etc., etc. Okay, so let's talk a moment about something you will need later. So there are 2 ways to run these hands-on workshop. One is by scanning this QR code, you will land on the code base from GitHub, and you can basically start the project. I suggest you to select 4 core, actually, will make it faster. And you can just click create the code space and wait until we are ready, and just wait a moment, it will build everything. If you, like me, prefer to run the code in your GitHub project, you can do the same. Here you will land in a GitHub repo and you can basically download the project and start in local. As I said, my suggestion is that you can do it right now. You download it and then we can come back later and we're going to start to code. But for now, I want to explain a bit more about what we're going to do. So we're going to go with tools that we have in the Arbitrum ecosystem that are available also in other places and try to see how they can be used and leveraged for building your projects. So let's start from the beginning. We know that there are different levels in this Buildathon, people from different backgrounds. So we want to really start from the beginning in this workshop. So first of all, Arbitrum is EVM equivalent. What does it mean is that whatever you can run on Ethereum with the Ethereum virtual machine can be executed exactly as it is on Arbitrum. And what does it mean for you as a developer? Like, it means you can use all the tools that people use on Ethereum. So you can use Ardat, you can use Foundry, and you can use also Solidity directly on Arbitrum. And that's great because those are really, really nice tools that helps you a lot to put together your smart contract, helps out every time that you need to do the integration and connection between front end and your contracts. But Arbitrum does not only have the EVM as a paradigm, there is also what we call EVM Plus. And the EVM Plus brings an SDK called Stylus. So what is Arbitrum Stylus? And we're going to spend a few words about this. So as we said, the other ecosystem, other EVM, most of the other L2s, most of the time they have the EVM as a foundational part. And so what does it mean? You can write a contract in Solidity, build it, compile it to the EVM bytecode, and then basically you get the smart contracts that they are the interaction, the way how you can interact with the EVM. And this is how it normally works. So in case of Arbitrum, is slightly different because you get exactly as for everything else. You have the possibility to write in Solidity or anything that compiles to the EVM bytecode, so including Viper and others. But together with the EVM, we have another virtual machine that is based in WASM. We're going to talk again about WASM later. But what brings us is the possibility to write smart contracts in any language that compiles to WASM. And so the Stylus SDK allows us specifically to write in Rust and then compile in WASM. And then through that, we're going to get a contract written in Stylus and in Rust, basically. Okay, what does Stylus bring us? So as we just mentioned, it's multi-language. So you're not just locked with one language, you could have others. So right now you have Stylus through Rust, but you can also have it through C++. If you, for example, have a library that you have built back in the days, you could reuse some of these logic directly through the Stylus SDK. Another very important bit is that if you write in Stylus, you are EVM compatible by default. What means is that basically you can run your smart contract alongside the EVM smart contracts that has been compiled, and it's basically interoperable. Another very important element is the fact that Stylus leverage WebAssembly. And so WebAssembly is pretty fast, it's safe, and it's quite flexible in terms of execution. So that is quite of an interesting feature to put together with Solidity. So long story short, through WebAssembly, you get the possibility to have heavy computation tasks from a memory standpoint or a CPU standpoint. So this is really when Stylus shine. And then, as we said, it's a multi-VM paradigm, so it is possible to call contracts written in Solidity and then invoke a Stylus contract, or vice versa. From Stylus, you can invoke a Solidity smart contract. Okay. So why tooling matters? So the truth is that when you work on Solidity, there is a lot of fragmentation between frameworks. You can end up to have a different way to write stuff. So understand what are your tools is basically the glue that puts everything together. And similarly, like even when you have smart contracts that are written in Rust, and they are faster and cheaper, that's great. But still, the VEX is evolving. So you can see that Solidity has been around for like years, and Stylus has been put in production since September. We started to develop a few years ago, and now is in production since September. So we are comparing a very different type of ecosystem. So expect some hiccups, but we are also here today to show that is working and you can really works with these kind of things already in production. So Arbitrum, in the end, it makes a cohesive approach through Stylus, Foundry, and Cargo Stylus to give you basically the possibility to write in Stylus your contracts, but also integrate those with Solidity. Couple of key concepts here. So Foundry is the one we're going to use today. It allows you to compile, test, and deploy in Solidity. Together with the Cargo Stylus, we add another level of features that goes on top, and is a CLI. It allows us to basically interact with Forge and having the possibility to integrate the Stylus contract in our code. And then we have the Nitro dev node. Is basically a local version for Nitro, which is the technologies that run the entire Arbitrum stack, both Arbitrum One and Arbitrum Chain. So this is a local version running in Docker, and you can leverage it to basically do whatever you need. And then as we walk through, we have the contracts, but we want to also use the front end. And so we're going to see a bit how it works to integrate a smart contract with the front end side. Okay, so what does it mean in the end, the dev stack in practice? Normally, you write the contracts, you pick either Solidity or Rust, you deploy them in Nitro, which is this local chain, and you can start to interact with the CLI that we provide. And then it's up to you to connect with the front end you prefer. In this workshop, we're going to work with React, but this is absolutely up to you. And then we can interact. We're going to interact in a bunch of ways from the command line and see a bit how it works, but also through the wallet and the browser. And finally, yeah, it's integrated. You can run also the test, and I'm going to see how to do it when it comes down to Stylus and Solidity. So few words about how Stylus works. Is actually very similar to Solidity, to be frankly with you. You build the contracts, and today we're going to do it through Foundry and Cargo. Once you have these contracts built that are running, what does it mean is that you can basically interact with them and deploy through Forge and Cargo Stylus deploy on your local chain. And after that, the contract is there. You can start interacted if you want through Cast or others, but then you needed to export those API in order to have the possibility to interact also from outside. And so that means most of the time, basically, your front end. And finally, we're going to walk through the code of the front end to just see how it works, how we can put together the code that we need in order to interact with the contracts from an actual front end. So as a users, how I can interact with the contracts. Okay, so a few words about this Nitro dev node. It's quite fast. It's run on your local machine or in CodeSpace if you're running through GitHub. It is pre-configured with a wallet. You have the RPC. You can both run Stylus and Solidity, and it runs through Docker. So nothing special here. You can interact with the CLI. We have pre-funded account. We're gonna see also a little script to distribute the funds in other addresses, but basically you have everything you need to start to build on your local machine or in your local environment through the Nitro dev node. And then how it works, the interactions between contracts. I think that's a very important bit, which is probably one of the most interesting features of Stylus and in general in Arbitrum, is the possibility to pick the right tool depending on the problem you're trying to solve. So while with Solidity, you really get all the goodies of the features coming from like an extended library, the possibility to use Open Zeppelin libraries and everything that has been built until today on Solidity, which is great. With Stylus, it is about performances. So as I was saying earlier, when you have, for example, a very complex ZK proofing system, or maybe an hashing function, like, for example, Open Zeppelin built this Poseidon hash, which is incredibly complex hashing algo, and it was not possible to have it through Solidity. So with Stylus, you can get something that works pretty fast, reliable, and it really shines with CPU and memory. And the beauty of these is that you can interact between the tools. So you have shared API that basically can be generated either by Stylus or Solidity, and then you can interact with those with whatever is the front end. So if it's the command line or if it's the actual UI, you can definitely use it, and you have a unified dev experience through the tools we use. Maybe this is interesting. Like it's a bit different when you build with Stylus compared when you build with Solidity, and is the deployment path that change. It's not big deal, but it's interesting to know what's happening behind the scene. So the source code is a text file exactly as for Solidity. Nothing changed there. But once we compile to WASM, which is like WebAssembly. So we compile to WASM, we deploy on-chain, and after that, we need to activate the contract on-chain. So there is this extra step. And once you do this, it's when basically you translate the code of WASM in the ARB WASM. So then it is a native code, and it is checked that it works as for the spec within the sandbox of the Arbitrum Nitro sandbox, and then you're ready to go. So then the contract, you get the address and you can start to interact with it. So as you see, is slightly different, but in the end is just running a CLI command. Okay, so WebAssembly. I don't know how many of you know WebAssembly. I think it is quite popular now in different setups. For sure, in the browser is now heavily used. Rust can compile to WASM, but what does for us is basically the possibility to have a package that can be deployed in multiple places, including your browser, or even a chain, or others, they are running WebAssembly, for example, serverless functions. So it's a very portable format. It's actually text-based. It runs the same across devices and different operating systems. It's very fast, almost near native execution speed. It's safe, it's sandboxed, memory safe execution, so really advanced. And it's also language agnostic. So as long as you can compile to WASM, you're good. And it is really a growing developer ecosystem. So it's a really great foundation to have WebAssembly in your dev toolbox when it comes down to blockchain as well. And then let's talk about Foundry. So we're going to use Foundry today, which is great. And it is written in Rust. And it provides basically a CLI called Forge that allow you to compile, deploy. We have tools such as like Cast to interact through the CLI with the contract, and then it supports unit test and also in general other goodies for the development environment. We're getting there, so we're gonna soon switch to code mode. Few more points around Stylus. We have also CLI for Stylus called Cargo Stylus, and it allows us to create the contract, deploy, check, and export the BI. A few other things as well. We're gonna see it through the workshop. And now, what's been built with Stylus? I think it's interesting now before we jump in the code to see other people's what they did. So a few examples are like Lit protocol, for example. They started to put together a quite advanced approach through Stylus. And they are basically an on-chain access control with key, permission, and identity. There is Fireblock, that is basically a system to have on-chain decryption, quite advanced, unlock data only when really some rules are met. And then Superposition, which is a very creative team. They're building also other stuff. This, in this case, was around the tools for pay user on dev for chain activities, and then CVEX, that is a trading platform using Stylus. Just a quick deep dive here with Lit. They have access control with precompiles. So I think we heard a lot about precompiles in other setup, but what gives us Stylus is really the possibility to write your own custom precompiles by leveraging Stylus SDK and Rust. So you can have basically your precompile directly deployed. You can deploy it in Arbitrum 1 even, or in your Orbit chain. And it's really, really fast. So Lit did exactly that. So it put together a way to generate their keys with their specific derivation path. They have signature checks that are basically precompiled, and they have this conditional access logic written in Rust, which is pretty complex with decryption, and yeah, all the secure verification sign on request. So what is great here is that Lit created all those features alongside with other bits in Solidity, but they are leveraging for basically performances reason Stylus. Fairblock is actually similar. A lot of encryptions and cryptographic primitives leveraged through Stylus. Is pretty nice project. There is also even like real-time decryption, which wouldn't be possible with Solidity. So again, I really want to stress that when Stylus shine is about performances, either because CPU or memory usage. I hope that you heard about Robinhood. They are launching, and actually they already launched in Arbitrum 1. They are working also in even more things within the Arbitrum ecosystem. They were quite vocal that they like it, also the stylus bit, but in general, they are using the Arbitrum tech stack. And they are gonna work on real world asset trading. You can already try today. Unfortunately, I can't show the video because I had to export for a form factor issue to a PDF, the presentation. So I'm gonna skip the next slide. But yeah, Robinhood is also using Arbitrum tech stack. Now we can start with the project and go to the code side. So we're gonna count. You know, developer often like to count when we start to work on the on explaining concept. And I think is the good thing here is it's simple, but it allows us to go deeper in what we are doing here and what are the tools we need to achieve that. So we're gonna have a little counter on stylus in Solidity and a React front end with TypeScript. And we're gonna see how we can wire this together. And yeah, we're gonna use this as a flow. So gonna go through this here briefly before I switch. But the project is a monorepo. It contains a few directory where you can find basically each of the components we're using. Really simplified from the root folders, you have basically the front end to a directory where we can find the contracts for Solidity and Stylus, Nitro dev node just for having it directly in the project, and then a script directory which actually contains just one little things, and of course the front end to run it. So step one, we're gonna set up the workspace and open the repo in GitHub Codebase. I think it's a great way to do it. If you prefer to clone the repo in your local machine, that's absolutely fine as well. And then we can start to explore the project. Step two, we're gonna review the contract, the front end, just check around the contracts, and then we're gonna start to deploy the contracts, get familiar a bit with the syntax, interact with the CLI, and run a bunch, try to understand how it works, and finally connect the front end to the React app. My suggestion is to have the code in front of you so you can do it as well. I will give you a moment also to do it on your own during the workshop. So that is how we're gonna do it. Are you ready? Let's go then. Okay, so quick reminder, you can download directly from the code space. Otherwise, you can download from GitHub directly. Now, let me do this, add to stage. Actually, let's, 1 second, remove. And then we're gonna switch here. Perfect. Okay, so we can jump here, so it's slightly bigger. Okie dokie. So first of all, we have here my monorepo. So first thing first, we can close this, perfect. Okay, so here on the left, we have the entire project, and there is a little readme here. You can basically follow me through these steps, and we're gonna go through it. First of all, these are the things you need. We're using PNPM. If you want, like you can also use NVM if you want to switch between node versions, sometimes it's useful. You need Rust and Foundry and Docker installed in your machine, and then the Nitro dev node, which is already here available. Without further ado, let's walk through a bit the repository. So it's a monorepo. You can spot here this PNPM workspace. These are the 4 projects. We can jump on Solidity. You see here directly in Solidity, you have your project is basically using Foundry. You have the source code and the test. Very simple stuff. We're gonna jump then here. or the tests, again, pretty simple. And then the tom file, which is basically what you need to run Forge here. Okie dokie. And then on the other hand, we have very similar to Stylus. You have the source code with the library here. Very simple counter, as you can see here, is actually Rust. You can use it with some macro to be basically used and make it payable or things like that. And then let's move on to the, well, very quickly, the Nitro dev node. This is like completely here. You can run it, is actually just a Docker file. And from here, you get everything you need, basically. Okie dokie. And then, yeah, this is the little script. Is just basically to disperse to a set of addresses funds, so we can basically interact from different angles. Okay, I think we can start. And I think the first things to do is to run the Nitro node. So I'm gonna go here, start Nitro. It takes a moment to initialize, and we are good. Perfect. So now Nitro is running, and I open another one. Okay, so first of all, one of the good things here is that we can run a different command from the root of the project. So we can start maybe by compiling and look a bit at the structure. So my project is called Stylus Counter, and I can start actually to build it. Okay, this has been compiled, and look, let's jump and see what we're doing here. Oh, sorry, I started from Stylus. I want to start it from Solidity first. Okay. And I'm gonna build it. Okay, so here I'm basically using the monorepo to launch from my root in any place. But behind the scene, we can go and check in the packages on actually what we're doing. And this one is basically just a simple map, Forge build. So if I want to go here, I can also do Forge build. And we get, oh, sorry, fair. So I'm in the wrong directory. So this is actually why I use this, is because from one single place, I can run it wherever I want. So in this case, I need to jump there, contracts, and then I need to jump in the contract of Solidity. And now I can do Forge build. Okay, fair enough. Okay, so that was one. The other things I want to do now is to go back here and run the deployment. Oh, come on. Okay. I'm compiling first the Stylus one. I'm gonna go back. Okay, I'm anticipating. I will let it finish. So I actually deployed first the Stylus one. Take a moment, but we can jump here. And here we go. We can check what we're doing here, because actually this is a bit more complex. So in the deploy local, actually, we are using the cargo stylus deploy. And here we're doing a bunch of things. So in order to deploy, we need to point to the dev node, and we need to pass the private key, and this is it. We can also do another things, but okay, now it's finished. So there is a command we need to run, which is this activation. So in order to activate it, we need to jump there, GD contracts, stylus counter, and we can activate the contract, but we need to, yeah, there we go. Oh, sorry, yeah, fair enough. It's telling me like, hey man, this is something you need to pay for. So you need a private key. And I can actually show you from where I'm picking this private key, because it's gonna be useful. So in the README, we put it together, all the private keys you may need. And so for now, I'm using this one, which is the main account. Of course, guys, don't do nothing silly with those private keys, because these are for test only, and these are public. So we publish those GitHub, these private keys on GitHub. So please don't use these private keys in your wallets, do anything stupid, because bots will steal any asset you put there. So please don't do that. Use it only in your local machine. Now I activated my contract. So this is my now the stylus contract, and I'm copying this stylus contract because later we will need it. Now, what I can do from here is perhaps jumping a moment to the front end. Well, let's wait for now. For now, we're going to leave it here. I'm going to create another bash. Actually, it's sh, and I'm gonna deploy what I said earlier, which is basically the Solidity one. So for Solidity, and I am in my one, so we're gonna say, please, let's do Solidity. And sorry, we already did that. Now we can do the deploy local. And in this case, we got it, is deploy it, and we got also the address. Let's check a second what we did here, but you can see it already. That is forge create, source counter, we do the broadcast, we have an address, we are specifying the private key, and then we have the chain ID, the RPC, and the constructor arguments. So here, as you can see, I'm doing most of the things from command line. Now I have them deployed, and you can basically do the same and deploy on your own. So we should have a bunch of addresses that we're gonna need in a moment. I wanna start maybe from this. Yeah, let's do this now. I think it's pretty cool stuff. So I wanna interact with the contract. So I'm picking this address, and I'm gonna use this cast. So what is cast is a CLI tool from Forge that you get in your local machine as soon as you install Forge, and you can call the contract. So what I'm doing now is to literally call the contract, and I'm just checking. I wrote too much here. Okay. And you got 0. Why 0? Is because we are invoking this get number that is in the contract. Let's have a look to the contract. So we jump in the Solidity one, we go here, and we search for get number, which is this one. And get number return this uint. If I remove this, you get this bit like not that useful number or not that easy to parse it. So that's actually the 0 in Solidity and in the EVM. So cast provide this little utility to parse to a decimal, so it's easier to read it. And that's one way. The other way around is that we can, for example, do cast send, and the contract is the same, 0x75. And this time we're going to add a number. So if we search in our contract, add a number, you see this is the signature. And basically is the only things you need to copy. Like you copy this, you don't need to pass the name of the variable. You just say like how you're going to parse it. And then here, this one is the parameters that I'm passing. So let's change rather than 1, let's write 5. Okay, I got my transaction. My transaction went through. You can see here in Node that is running. And now if I go back here, I can come and say, okay, can we call it again, my get number? Boom, now it's 5. Okay, so I will leave you maybe 1 minute or so. If you want to try another command, it would be interesting to see how would you, for example, do the multiplication with this mole number. So let's wait a second, try on your own. I will need music, a minute of music. And then I can try on my end as well. We'll do again send. And once you wrote once, it's easier to change it. So this time I'm gonna use mole number, and this time I multiply 3 times. So multiply the current number by new value and execute. And now I call again, and it's 15. So as you see from command line, I'm interacting with the contracts. I can play around and understand a bit how it works. And that's great. It's a good way to get acquaintance with your code that you are writing. Okay, so in this case, cast is basically your front end or the CLI, I would say. Let's have a look to our front end from an actual end user perspective. So we need to make it sure that the contracts are correctly configured. Depending on the order how you run this, it could be different. So I'm gonna pick this as the Solidity code, and then I will jump in the other to use this as a stylus one, which I think is already, is it this one? So yes, perfect. Okay, so this is how I'm configuring my UI. I always prefer to see a bit the UI, so let me show you not this, but this one. Yeah. So this is the UI we are interacting with. If I reload this page, it will fail actually because I didn't started the server. So let's do that. I will create a new one, and we can basically pm filter frontend dev. So this is now starting. And if I go back here and I reload, we're good. Perfect. So we're getting there now. And we want to check a bit how this works. first of all, I just show you the contract addresses we need to configure. And now I want to show you a bunch of components we have here. So one very interesting is the Web3 context. So Web3 context, it is basically pretty useful way to put together in React a context that you send around. So this is a Web3 provider. I don't know how much you know about React, but basically this is one of the way that you can create of wrapper functions that you can reuse across your interface. And here we are basically configuring everything we need. So you have the chain ID, you can pick the accounts, you can pick the first address, and then you can create the wallet connect. Create wallet connects come from VM. And you can have it your wallet or the public one. Public one is useful to interact with all the public call, rather than the wallet is basically every time you send a transaction. That's the two main differences you should consider. And the good thing of the web context provider is that you see these children. It means that then you can pass any type of components and get the same functionality. So you get the public client, the wallet, the address, chain ID, connect, disconnect, everything in one single component that you can use as you prefer. Let's go in the Solidity. And I think there is this. This is just like cosmetic. So it's just to explain what we are using. And you see that we are basically going through the contract address. That is the one we configured here. And so the component just pick the contract and it pass it, and then it works. Same for the stylus, is almost the same. We could have created one single component and just change a bunch of configuration. But let's go now in how it works, the actual code, so the counter itself. So use Web3 is our basically webhook. Sorry, not webhook. Is just like a React hook. And you have it here now. Use Web3 and you get public client, wallet, address is connect. Let's go how it actually works this, because is pretty nice. So read contract is the equivalent, if you want, of the cast we were doing earlier. And so here you just pass the address and then the ABI. So that's the very one. I didn't show you how to generate the ABI. I think is a good time to do that. And we can have a look to them in a moment. But let's jump here. Sorry, I have them here, but I want to go back to my code and basically using a cargo stylus, and we have the export. Now here I did a bit too much, but I want to show you that you can export the ABI. Now I'm in the wrong directory, so I'm not going to do that because it will fail. So let's jump and contract stylus counter. Okay, now I'm in the right place, and I can go cargo stylus export ABI. And so I can do it in two steps. The first one is just exporting a Solidity interface, which is very useful. So this is my stylus contract, and I'm exporting the ABI. And so if I am in Solidity, I can use it, and I have the interface. I can now invoke that as if it was a contract. But in this case, we want to have the ABI for a front end. So the simplest is to do this with JSON, and you get this JSON. Now, what I noticed is that you get also a bit too much output. And so I added this little pipe, and you can basically tail, and then you can basically, is already better now. You remove the line, but if you want to be even nicer, you use JQ, and then you basically ask to be formatted. And now you get it, a nice one, very well formatted. And here, look, now search for example, multiple number. Here we go. And this is how we are invoking. So we send an input. We need just to pass this int, and then we have the name of the function. So these things are required in this function above. So here we are just doing the cast. And let me find out, where is it? Increment, here we go, number. So this one, you see, it doesn't require arguments. So the inputs are nothing. Indeed, here we don't pass nothing. And the function name is number. So this is exactly what we need in order to execute this function. And so final bit, if you want to export your ABI, you target the front end and you're gonna produce them here. And here we go. That's how I did it, basically. Okay, so now that we have these, I think we can start to jump in the front end and try to do it on our own. So, okay, let me jump in the front end. And now I need to, 1 second, this doesn't reload. Why not? Okay. Okay, so this is a blank new wallet. I have nothing here imported. So I'm gonna jump for a second to find a private key in my list. And I'm gonna add here. And now I'm gonna call it dev. Actually, let's call it Nitro dev1. Okay, so now I have an address. Okay, now I'm connected, and this is one, and this is the other. So as you can see, earlier we were playing with that, and we did everything we wanted. Little trick here, our balance is 0, so we didn't have ETH, which is very annoying. So we have something to solve that. So we can go back to our cursor. And as I said at the beginning, we have a little script in the root, which is this one, script and fund. So it does really little thing, but it's useful for that. So basically it goes through, it leverages the private key we have, and then we disperse basically 1 ETH on each of these address. And so we do this. Okay, now we have like a bunch of those. If I go back here, now we have 1 ETH. So now we are ready to send a transaction. Like we already saw how we read. Let's see how we write. So let me go back for a second on the counter page, and not here. Where is it? Counter. Perfect. So this is how we read, and now we would like to write. So in this case, we have a little UI, but it's not nothing complex. It's just basically leverage the ABI again, and there is this function name. And we wrote this function that accept a name of the function and the arguments, and then it built the write contract. And so the write contract, what it does is to make it sure that you also send the value, which is basically the ETH required. So if now we search for these, I'm gonna find, oopsie, For example, we have increment or set number or add number. And so we just refactored our code in order to reuse the right contract. And in the end, the right contract is just a matter of leveraging the right contract that comes from wallet client. And the wallet clients come from the Web3, which is this Web3 context that we put it together. So this is entirely built in with VM. You can use also other stuff, including like maybe a layer above a VM, which is WAGMI. But once you have these Web3 context, you can basically leverage whatever you want and go through the things you need. Okay, so let's try to wrap up this here now. I want to just, for example, set the number maybe back to 0. This is now asking me to sign. It goes through and boom, we got the 0. And the balance has been updated. And we have the transactions. And if we go back here, we can see also Nitro, Dev Node, everything we need. So just in interest of time, now it's a little hour we are running these. And I think we went through multiple steps. And you can definitely use other stuff that you can see here. But I think this is a great project that you can use to basically check a simplified version to use Cargo, use Solidity, use Forge, having the Nitro Dev Node directly in your machine and play together with Stylus and Solidity in one single place. So that's how I see it in terms of leveraging this project. I will go back to the slides. So I will pause now here. Let me remove this, add to stage. And yeah. Here we go. So if you want some help here after the workshop, you can definitely go through the Arbitrum documentation. There is a lot of things around Stylus and how to use the Dev Node. There is this awesome Stylus where you can read more, but particularly about the Dev Tooling workshop, you can download it and use it. That is absolutely available, and it is already open source today. So what comes next in your journey here at the open house today with myself? First of all, you can continue to build it. If you didn't sign up for the open house India, you can still have time. You just need to scan this QR code or go in openhouse.arbitrum.io. That's also a good way to start. And you can basically bring your own code or start from scratch if you have an idea. My suggestion is always try to do this not just alone, but try to also have other people that they are interested in the same journey you're taking. So it's easier to build something meaningful if there is like 2-3 people working together. So that's my suggestion. And then my suggestion is also to stay updated. We have now a builder block newsletters. We release every 2 weeks or so some updates. So my suggestion is to sign up to it, please, and you can stay in touch with us. Last thing, thank you so much for joining today and in this walkthrough about the tools. Maybe a couple of recaps here. We ended up to work both with Solidity and Stylus. We put together the contracts, we deployed them, we saw how to do it, and particularly we interacted through Cast, and we saw how you can interact through either the CLI or put together the front end. In this repo, you can find basically the entire projects, including the contracts, the front end, and the scripts to distribute the funds. Last thing, this is part of the open house. It's a multi-step activations. We are currently on India, and we're gonna plan to be in other places later. But at this stage, we have the online Buildathon where you can sign up and participate to win the prizes. There are up to 33,000 USD dollars in prizes for the best projects, and you can still have time to sign up. Please scan that, and I'm looking forward to see you around in the next days. You can reach me in Twitter on About Law. This is it for today. Thank you so much for your attention, and have a great rest of the day.